how much power can you theoretically send through an 8-pin or a 6-pin to your GPU? Now this video isn't about what is in spec or not in spec, but what is theoretically possible and safe-ish. Now let's look at some numbers. Now why are these numbers both the same and way higher than you think they should be? Well, let me explain. Surely more pins mean more power, right? Well, yes and no. So let me show you a 6-pin pinout. So on a 6-pin, you have 3 12-volt lines delivering power and current to the card, and 3 grounds. And so you think, okay, 3 and 3. That makes sense. How about an 8-pin? Surely it's 4 and 4, right? Nope, it's 3 and 5. So essentially it's a 6-pin with 2 ground pins tacked on to the end of it. What the extra 2 grounds are used for? Well, one is used as a current sense. A sense pin. So that's used in a variety of applications. And the other one is just another ground. Now, how about the new 12-volt connector for the GPU? Well, that's just 2 6-pins essentially. So 6 pins for 12 volts and 6 pins for ground. So again, theoretically the same draw of power. So power, let's break this down, information down. So we use 12-volt cables to deliver the necessary current to the card. And what we typically measure the card's power usage is in watts. So the formula for watts is like VI, which is voltage and current, voltage multiplied by current, I meaning current. So for example, if you take something like a single board computer, like a Raspberry Pi or something like that, they will typically use about 5 volts and maximum maybe around 3 amps, depending if you're using like USB devices or whatnot. So it's just 5 times 3. So that's about 15 watts of power usage, maximum draw kind of thing. Do we need 3 pins or 5 pins or even 6 pins used as ground? That's always up for debate, but anyone's guess. So yeah, now the sense pin on the 8-pin connector, what's that used for? Well, it's kind of like, you know, yo, I have 8 pins plugged in, I can turn on now. A little bit like that. So anyway, on to the next part. So I hear numbers like 75 watts, 150 watts, 300 watts. Or you hear like, oh, an 8-pin can deliver more power than a 6-pin. Well, you know, if the only difference is 2 grounds, I don't really see how much you can add. An infinite amount of grounds, you're not going to draw any more power. Unless, you know, I believe some GPUs are like, hey, it's okay if you plug a 6-pin in, but if you plug an 8-pin in, I'll let you draw more power through the connector, because it's some kind of, you know, BIOS setting that they have in the card. So it's like, yo, you got an 8-pin? Alright, I'll try and pull some more power for you. So let's talk about things that affect power draw. First, let's talk about cable gauge. That's probably the easiest. So typically the cables in your PSU are 18 gauge. And, you know, the average 18 gauge I've seen can pull about 10 amps. So, you know, if you go like, well, the best I've seen is like 13, but let's use 10 because it's easy math. So if you go 12 volts multiplied by 10, that's our voltage times our current, you'll get our watts. So 12 times 10 is 120 watts. So one cable can deliver 120 watts. 2 cables 240, 3 cables 360. So 360 watts through 3 cables in a pretty average 18 gauge cable. Of course you can opt for something which I've done before is, you know, you go for another gauge cable like 16 gauge and you can get a few more amps out of that if you want. Now another important thing sort of is cable length. So cables, they're like big long low ohm resistors, and the longer your cable is, the more resistance your cable has. So to reduce the resistance, you have a shorter cable. And thicker cables also help to reduce the impact of resistance. Yeah, just the same as short cables. Now next are the actual pins. Now pins, I've made a lot of cables, but pins I haven't really switched around with a lot because I'm just using the same connectors, keep everything kind of in spec. But yeah, pretty much, you know, more surface area on the pins, the better. I don't have a big cable. Imagine this is the cable, nice big thick cable, and then you have a connector, which is like this. Now, do you really think like such a thick cable can transfer, if it's used at its limit, maximum, can transfer all the current it needs through this tiny pin? Probably not, and that's probably why things melt or pop or crackle. So yeah, will it create a bottleneck? Maybe, maybe not. Not likely, likely. Finally, the power supply. If you have a lot of things hanging off your power supply, you simply won't get the current you need to push that 300 plus watts. Bigger power supplies are better? Yes and no. There is something to be said about the quality of a power supply, but that's a whole nother long video. An easy way to find a decent power supply without doing too much research, you just need to pick something that's like 80 plus gold rating, and then once you've got your list of 80 plus gold rating power supplies, you can start looking for some reviews and whatnot, and what to look on the label, what to look for on the labels. So I guess this might be like the middle part of my video. So what can I say? If you want some proof whether you can or cannot send this much current through these cables, you can probably find somebody on YouTube that's done this before. So yeah, don't shoot me yet. I'd say GPUs kind of have a soft limit. The soft limit is, when I refer to a soft limit, it's kind of like it can do these things, but you just need to unlock it somehow, you know. So you can find various BIOSes that have unlocked power limits, or you can just like hard mod something on your GPU, like I think most of the GPUs, they measure using a really low ohm shunt resistor. It's kind of like they'll measure what comes in here and what goes over here, and then they'll have a kind of calculation. In my head, I can't think of it right now. It's just like this is like this side minus this side is the current draw or something like. Well, I guess that's the end of this video. I'll leave you with a little bonus rant or possible tangent, a little off script, as I didn't really write anything extra. A little bit. Okay. So here's one. Hey, I got this power supply with only one 6-pin, and my GPU needs two 6-pin, I guess. Can I use this adapter? And it's one of those adapters where you have your 6-pin and you plug another one in here, and it kind of like that makes two, one into two. Yeah, absolutely. But first, you know, you need to question, why does my PSU only have one 6-pin? Now, those kind of PSUs, I can pretty much assume it's from like an OEM like HP or Dell, and they made them specifically for the system that they're selling. Doesn't mean that you can't use an adapter, but you just need to look on your power supply. There will be various numbers, but one is the 12-volt rail and how many amps they can handle. Like, I think on a cheap OEM it's gonna be 30 or less than 30, something like that. 40 is a nice number to have. More than 40 is really good. It just means if you try to pull too much current through the cables might be fine, but the pins just might give up, or your power supply will just give up, and you'll be like, why is my computer turning on? It's because it's trying to draw too much power and I don't have that power. Alright, next one. But I heard adapters were bad and dangerous and stuff. Okay, here's another one. But I heard adapters are dangerous and stuff. Ever seen a PSU with a single, like for example, let's use this, with a single 6-pin and another 6-pin kind of hanging off it? Well, that's kind of like your adapter, right? And you would assume that a power supply manufacturer will send a power supply out and not give you anything that will just destroy your computer. Next. All right. Yes. Okay. So this is about chaining and connecting a whole lot of adapters together. So when you have a single 6-pin cable here and you put an adapter on the end, what happens is you're essentially creating a parallel of that 6-pin. So you'll have 12-volt cables coming this way, 12-volt cables coming this way. But the thing that divides when you connect these things in parallel is the current. Okay, so current will be divided both ways, but also your bottleneck is now the single 6-pin cable. Now if this single 6-pin cable is really crap, like let's say it's like 8 amps, then that means you're just going to get 4 amps per 12 volt line coming out. So it might be enough for your PSU, it might be enough for your GPU, but if your GPU is really power hungry, then you're just not going to get enough power through that. Next, yes, another important one. Check your TPUs. Check your power supplies amperage on the 12-volt line. It's really important if you want to run a powerful GPU or two. I've heard melting and stuff. Melting cables and stuff. All right, sure. Cables melt. That happens. Let's take for instance a low quality 18 gauge cable. Now the insulation, I don't actually know what temperature the insulation will melt at, but silicone or plastic, I'm sure fire will melt it, so that's around 600 or something degrees. Or boiling it 100 degrees, is that going to melt cables? No, don't think so. So unless if your cables are like hotter than your CPU, I think you're okay. But the things that do break, or the things that do pop or crackle or snap, pepper, crackle or pop, are the actual pins. Now the pins are sort of like I guess they'll be like the weakest link in the chain to send power to your GPU. And so if anything goes wrong, it's there. So you got it melted, your 6-pin is all melted and the pins are all burnt out. So what do? You just cut the end off and put more pins on, right? Yeah, that'll fix it for a little while, but you haven't fixed the underlying problem, which could be a great many things. Could be something wrong with the GPU. The GPU is just like, hey bro, I need like 100 amps power supply, give me 100 amps. And the power supply is like, okay, and that doesn't work. Or the power supply is just crap, and then you might have just had a surge or something, and so damage. So replacing the pins and replacing the cable, replacing the head is not fixing the problem. It's just, brushing it under the rug. So yeah, ultimately there are limits in place. I've just labeled like a small limit that you can kind of unlimit a little bit, which is the cable, the power supply. When it comes to the GPU, there are other various limits in place on the GPU. So that's a whole nother video uncovering those, not uncovering, just like revealing those limits in place. Okay, cool. So I saw someone mention something like, oh, my GPU needs 300 watts, so I need 2 times 8-pin or 6 pins. Alright, so let's use this example. So you have a single 8-pin that splits into 2 8-pins. Will it work? Yes, absolutely. Okay, so what's stopping that single 8-pin from delivering all 300 watts that you need. While essentially it's nothing. The only thing that artificial kind of limit is the GPU. GPU kind of wants to load balance these things, you know. GPU is like, hey, it's kind of safe if we have these 3 pins of the 8 pin delivering 12 volts to one of our 8 pin connectors and another one delivering to the other 8 pin connectors. So I guess that's the reason why you have 2 for like a 300 watt load. But again, if you just add an adapter to it, you're not really load balancing it. You're just, well, you are load balancing it, but you're just putting the stress on the connector of the cable. Well, not the connector, you're just making a bottleneck somewhere. Alright. Yeah, you can compare it to, like, let's say you have a hose, right? And then you're filling a bottle, and then the hose is pouring water in here. Cool. And then you decide to attach an adapter to the hose where 2 come out. Now, is that going to give you more water, less water, or the same water? So think of that water as like the flow of current. So you can decide whether you want to split the cable in 2 and pour half as much through the 2, or you just have one cable pouring all of it through. And well, yeah, it's kind of like you are in the kitchen and you turn the tap on, and then you go to the bathroom and you turn the tap on. You'll notice the kitchen water's pressure will drop a little bit. That's because you've divided the current. Alright, next. So yeah, this is all just a small part on how your GPU decides how much power it needs, how much power you can give your GPU. Maybe in another video I'll discuss various configurations and on how the actual GPU decides how much power it needs, or where the power goes through, or how to change the settings. Yeah, limits and circumvention of those limits. Comment, like, and all of that stuff. If I said anything wrong, I'll pin your comment, or I'll pin a comment, or I'll make an amendment.